Hello everyone, let's see this question. Two motorboats that can move with velocities 4 meter per second and 6 meter per second relative to water are going upstream in a river. When the faster boat overtakes the slower boat, a buoy is dropped from the slower boat. Okay, so you have one faster boat and you have one slower boat. So the buoy is dropped from the slower boat. Okay, so this buoy, I'll just drop it here. Okay, so after a lapse of time interval, both the boats turn back simultaneously and move at the same speeds relative to water as before. Their engines are switched off when they reach the buoy again. If the maximum separation between the boats is 200 meter after the buoy is dropped and water flow velocity in the river is 1.5 meter per second, find the distance between the places where the faster boat passes by the buoy. Okay, so this one right here, it will travel a longer distance and come back, and this one will travel a lesser distance and then come back, right? And it is given to us that the maximum separation between them is 200 meters. Okay. Maximum separation is 200 meter. Now we can see that the faster one is moving at 6 and the slower one at 4. So in the frame of the river we are seeing everything. So we can say that the maximum separation which is given to us, we can write that 200 as relative velocity, which would be 2 into time taken t. So that gives us what? 100 seconds. So that means for 100 seconds these two boats go forward, and at this instant you have a maximum separation, and then in the next 100 seconds they turn back and return to their original position with respect to water. Okay, so we have to find the maximum, we have to find the distance between the places where the faster boat passes by the buoy. So the total time for this entire trip is how much? It would be 200 seconds. Okay, so 100 seconds while going and 100 seconds while coming back, and in this entire duration the buoy, with respect to river it is stationary, but with respect to ground it would be moving with a velocity equal to the velocity of the river. Hence the distance travelled by the buoy with respect to the ground would be how much? VR into capital T, and VR is given to us as 1.5, so we get 1.5 into 200, which is 300 meter. So that means in this duration the buoy would have traveled 300 meter with respect to ground. That's our answer.